Welcome back. In this lesson, we will learn about the combinations of cells. Combinations of cells. We can have series and parallel combination. We start with series combination. Here we have two cells of EMFs E1 and E2 and internal resistors R1 and R2 are connected in series with their polarity in the same direction. So here we have the first cell with EMF E and internal resistance R1 connected to the second cell with EMF E2 and internal resistance R2. They are connected with their polarities in the same direction. Now the effective EMF between the two ends of the combination E is equal to E1 plus E2 because they are in the same direction. And the effective internal resistance R is equal to R1 plus R2 because they are in series. Now let us connect these two cells in series but with their polarity in the opposite direction. Here we have the first cell with the EMF E1, internal resistance R1. The positive end is on the left side for the first cell. And here we have the second cell. Its positive end is on the right side. And we have the resistance, internal resistance R2. So they are connected together in series but in opposite directions. So the effective EMF in this case between the two ends E is equal to E1 minus E2, assuming that E1 is greater than E2. But the effective internal resistance will be R is equals to R1 plus R2. Now take the case of parallel combination. We have a parallel combination of two cells here with EMFs E1 and E2 and internal resistances R1 and R2. Here is the first cell with that boundary is the structure of the cell, and the EMF is E1 and internal resistance is R1 that is being connected to another cell. The second cell with EMF E2 and internal resistance R2. We put it into a box. And you connect the two ends together so they are now in parallel. Positive ends are connected together, negative ends are connected together. They are in parallel now. and between these two ends you will get the effective EMF. Let us assume that E1 is greater than E2. Then the current will flow in this direction, I. The total resistance, let us put a loop A, B, C, D. The total resistance in the loop A, B, C, D, A equal to R1 plus R2 net EMF in the loop A, B, C, D, A is equal to E1 minus E2. Therefore, current I is equal to E1 minus E2 over R1 plus R2. Then effective EMF E is equal to EMF across AB or AD or BC, not AB, AD or BC. So E is equals to E1 minus I R1 that is E1 minus I value is equals to E1 minus E2 upon R1 plus R2. So E1 minus E2 over multiplied by R1 over R1 plus R2. This is actually the EMF worked out along the side AD, I think. AD. That is, now you cross multiply, or you multiply this denominator with E1, you will get E1 R1 plus E1 R2 minus E1 R1 plus E2 R1, the whole divided by R1 plus R2. Here E1 R1 and the other E1 R1 cancels out. So what is left here, the effective EMF E is equal to E1 R2 plus E2 R1 upon R1 plus R2. Now this is the equation for the effective EMF of a parallel combination of cells. Effective EMF of a parallel combination of cells is given by E1R2 plus E2R1 upon R1 plus R2. Now we will work out the effective internal resistance because the two resistors are connected in parallel. The effective internal resistance R is equals to R1 R2 upon R1 plus R2. So you have got both the equation. Thank you for being with me for this short lesson. Thank you very much.